when I take out the duplicate, my possible rational zeros are 1, 2, 3, 6, 1/2, 3/2, 1/4, 3/4. Are we done yet?
No.
No. Okay, remember I said you need plus or minus for everything, so I just listed all these as positive. You got to repeat that whole list and make them all negative. -1, -2, -3.
Dang.
Yes, dang. That's correct. And that's why we don't want to do this for every single problem.
So are we done yet? I feel like
now we're done.
No, we are?
Now we're done.
Oh.
Now that's just the possible rational zeros. Now, are all of those going to be actual zeros of the function?
No.
No.
So now there's 16 of them, right?
Mm-hmm.
So we would, for those two problems that I asked that, we would write that out.
You have to write that out.
Why are we doing this?
Because this is a holdover from before calculators. Okay. Also, this lets you know that these are the only things that could be zeros. Okay. Now, how would we go through and check these?
We could graph it.
Well, there's really two ways you could check them. You could plug them all into the function. If they give you 0, then they're zeros.
Oh, I get it.
Or you could divide by all of them. If they give you a remainder of 0, they're zeros.
How do you divide by all of them?
Okay, so let's talk about dividing. So I told you guys we were going to do synthetic division, but we didn't actually do it.
She was going to do it anyways.
Now, Purple Math has a good lesson on synthetic division. So if you need to review this, Purple Math has a good lesson on it. Okay, it's better to just do an example here than to actually try to describe the process. Honestly, I don't know if I can really even describe the process without numbers. Okay, so let's say I want to divide let's use that example we just used, that function, 4x to the third minus 2x squared plus 3x minus 6.
Are we doing this on the paper we're turning in to you, or?
You might want to do this on your notes so you have an example there. 4x to the third minus 2x squared plus 3x minus 6. Okay? Now, if I try to divide that by something on my list here, I should get a remainder of 0. If I try to divide by something that's not on my list, I should get a remainder that's not 0. Okay? So let us try 6. Okay? So if I want to check that 6 is a 0, then I need to think of this as dividing by the factor of x minus 6. If you divide by x minus 6, you're really checking x equals 6. Okay? Because 6 is the number I would plug in there to get 0.
Okay, that makes sense.
Okay? Alright, so to set up your synthetic division, you want to start with your highest power of x, and then list all the possible x's decreasing downward. So, like, if I start with x cubed, then I would have x squared, x, and then I would have a constant term. I'll just call that c. C is for constant. Okay? Now, it's important that you list all your decreasing x's, even if they're not in the equation. Okay? So if I don't have an x in my equation, I still need an x column when I'm dividing.
So if you only have x to the third and x to the squared, you have to put x. Okay.
And c. Okay, you have to have all the decreasing ones starting with your highest power, even if they're not in your equation.
Weird.
Okay? Now make a little box here and put the number you're checking in that box. So I'm going to put 6 there. Now underneath your x's, you want to put your coefficients. So my coefficients are 4, -2, 3. My constant is -6.
Oh, and if the x wasn't in the equation, it'd just be 0, wouldn't it?
Right. If your whatever number is not in that equation, you put a 0 in that column. But it's important that you don't skip any columns. Okay? Now leave a space and draw a line below that. Okay, this is how you set up the problem. Okay, the first step is always to bring down the number in your first column below the line. Always the first step. That's the step everybody usually forgets. Bring down the number in the first column. Okay? Then you want to multiply. 6 times 4 is 24. So the number in your box times the number below the line. 6 times 4 is 24. Put that in your next 5.
Wait a second.
Okay? Then you want to add downward. So -2 plus 24 is
22.
22. Okay, and then you repeat that process all the way across. So you multiply 6 times 22, put that in your next 5, and then add downward.
Jeez.
What is 6 times 22?
132.
132? Now I am not going to get a remainder of 0.
That's apparent.
What?
That's apparent.
Yes. So then 6 times 22 is 132. Add and you get 135.
Then you multiply that by 6 again.
Multiply that by 6 again. What's 6 times 135? 810?
Yeah.
Okay. And then -6 plus 810 would be 804.
Jeez.
Okay? That last number is your remainder.
So since we didn't get a remainder of 0, this is...
Not a 0.
Okay.
As a function. Now, it's just one of my possible ones. So if you check the possible ones, you could get a remainder of 0. But
So
you don't.
you do this to get a remainder of 0?
When you find the right one. Yes.
So you gotta go through all 16 rows?
No. That's what they show in the examples. But in the examples, what you'll see is that they magically pick the right ones to check. They never check any that are wrong. Have you noticed that? If anybody's been looking forward at the examples? They never check any that don't work. So how do they know which ones work? They're looking at the graph.
This is like learning how to use a card catalog. Like
Yeah.
we're never, we don't need that anymore. I've never used a card catalog in my life.
Okay. Now, but how do I interpret this here? 804 is my remainder. My quotient here, it shifts your columns over 1. So if 804 is my remainder, then the x column becomes your constant column. The x squared column becomes your x column. And then x cubed becomes your x squared.
Say what?
This is how I interpret the quotient, the answer. When you divide, side, you get a quotient. So my quotient would be 4x squared plus 22x plus 135 with a remainder of 804. Okay, do you guys remember how to write your remainder in long division?
We are.
You can write it with an R. You can also write it as a fraction. Okay, you do the remainder divided by the
1.
divisor,
Oh, divisor.
which in this case was x minus 6. Put your divisor by, you put your remainder over what you divided by.
And that's the answer.
That would be your quotient. If the question was just for me to divide, that would be my answer.
We don't encounter that, do we?
Hmm?
We don't encounter that in my math lab, though, do we?
No, you would. You could. Let's find one.
Yeah, let's do it right now.
Let's do it right now.
It's up toward the back,
Yes. Now this is multiple choice, so it's kinda easy. You guys wanna try 21? Alright, so 21 I've got x to the 4th
So are we gonna try doing our grid first? No, wait. Never mind.
Good guess.
Okay, in that one we don't have an x to the second, so that's gonna be a 0. Right?
Yes. Okay, so I get x to the 4th minus 5x to the 3rd plus 9x plus 9 divided by x minus 2.
So it's basically, we're dividing by 2.
You're dividing by 2. You're checking x equals 2. Okay? So I've got x to the 4th, and then I want to put all my columns in, x to the 3rd, x squared, x, and a constant column. And I'm checking x equals 2.
X to the 4th is 1.
Okay, my coefficients are 1, negative 5. X squared is missing, so I put a 0 in that column. Then I get a 9 and another 9. Okay, now that we've set this up, you guys try it.
Okay.
Try it for a second. See if you can remember how to do the division process here. Okay, and I'll do it up here and just not talk if you need to watch me. Okay, so I bring out my 1 first. Then I do 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. 0 plus negative 6 is negative 6. 2 times negative 6 is negative 12. 9 plus negative 12 is negative 3. And then 2 times negative 3 is negative 6. I just didn't write down the negative. Negative 6. And then 9 plus negative 6 is positive 3. So I had the right answer. I just didn't write down the negative on the last one there. Yeah. So my remainder is 3.
Okay, on your first one now, you got x to the 4th power.
Uh-huh.
You got your 1, and then you draw the line down there. Is that your next step?
You just bring down that first number first.
Okay, bring it down. And then multiply. Yeah, okay.
so 3 is my remainder, -3 would be my constant, and then x squared, x to the third.
Okay, now what happens when you get to that square? Do you still include it? You got a -6 there, even though it was a 0.
Yes, you have to have the x squared there. You have to have all the columns there even if they're not in your equation. You just put a 0 in for them if they're missing. Okay, do you guys want to try the next one? Go ahead and try the next one.
Can you go back real quick to your notes? Sorry, thank you.
Okay. But you always add these, right?
I'm gonna always add them. Oh, going downwards. Yeah, you always add going downwards. Well, yours is 3. You need 3 in your box. That's your problem. You're doing part of my problem and part of yours. You need a 3 in your box. That's why your number's
She does that a lot.
Yeah. You might just want to start that over.
Okay.
I'm sorry, I already did that.
So you guys already did the division one?
Yeah.
And then 2, -10, 31. That way. No, you're missing your s squared. You have a 0 there. And then 31 and 9. Yeah, you should need a 0 in that column. Yeah.
Because I'm adding those together.
And then you put 4 in your box.
Why?
Because you're checking.
Okay. My brain just went, why do I want 4 in the box?
They're wanting you to go.
Alright, you ready? Ready?
No, first break down your 2. You gotta break out your first number first before you
Oh, I
multiply.
see, the 4.
You only multiply below the line.
Should I do it now?
2
little confusing zigzagging up and down.
You gotta practice it. You guys know that? Okay, so how do we use this to find the zeros? Okay, well if you get a remainder that's not 0, then it's not a 0. If you get a remainder that is 0, it is a 0. Now how do I know what to check? You can know what to check by looking at the graph. Okay? Now sometimes they give you one to start with. Okay? So it says one solution is given, use synthetic division to find the remaining solution. So that means if I look at the graph of this thing, I'll see it cross the axis at 2. Because 2 is the solution they gave me. Now I told you guys we were going to use the graphing calculator. Okay, so sometimes you want to start by just looking at the graph of these things. Because sometimes you can pick out the zeros on the graph. So I've got x cubed plus 2x squared minus 5x minus 6. Okay? Now do you guys remember how to find the zeros? If they're not whole numbers.
Trace.
I saw some of you guys when I was walking around, some of you guys were sitting there trying to fool with us and you can't quite remember how to do it. You want to set it equal to 0. So type in 0 for your y2 and then find the intersection. Okay, that's how you can find the zeros if they're not whole numbers. But I do have whole numbers in this case. So this question told me to find the remaining zeros using the synthetic division, but do I need to do that?
No.
No, because I can see the remaining zeros on the graph. Okay. So my remaining zeros for this problem are -3 and -1.
So in 25, what are they doing? They're giving you a point?
Okay? Now, here's what they wanted me to do. They wanted me to divide this function by the 0 that they gave me, which is 2. So let me set up my division problem here. So I've got x cubed plus 2x squared minus 5x minus 6. And they told me to divide by 2, so I put 2 in my box. Okay, so bring down your 1 first. Multiply. Then add. Multiply. And add. Multiply. And add. Okay? So, I got a remainder of 0, which I expected because they told me that that was one of my zeros. Okay, so this means that the function factors to my remainder, this is my constant, my x squared. Okay? So x minus 2 is one of my factors, times x squared plus 4x plus 3. Okay? So it means if 2 was a 0, then x minus 2 must be a factor of that function. And this is my quotient. Now to find my remaining zeros, your remaining zeros are going to come from your quotient. Okay, so we already know x equals 2 is our first zero. I can get my remaining zeros from that quotient. Now what can I do with that quotient to find zeros? You can factor it, right? So how would x squared plus 4x plus 3 factor?
X plus 3 and
X plus 3 and x plus 1? That sounds good. So my remaining zeros are -3 and -1. Which is what we saw in the graph. Okay? So always look at the graph first and see what zeros you can pick out from the graph. Sometimes you can pick out all of them and you don't have to do this. Okay? Because I can see all three of them on my graph. Okay, I can see -3, -1, +2. Okay, so always look at your graph first and see what zeros you can pick out. Sometimes you can actually get all of them. Okay, now it says remaining solution, so I don't need to include the one that they gave me. So I don't include 2. I just want to tell them -3 and -1.
Oh.
Okay? Now if they don't give you one, then you would list all of them. But if they gave you one to start with, you don't want to list that. Because they already told you that one. Okay, you guys want to look at 26?
Yeah.